This video will be a review of adding and subtracting fractions. Be sure the date and topic are at the top of your page. The essential question for this video is how do we add and subtract fractions? When we add or subtract fractions, we have to think about one very important thing, and that is the denominator. As I'm sure we all know, the denominator is the bottom of our fraction, right? So it's here on the bottom of our fraction, and it's the number of pieces or parts we're breaking our whole into. Just out of curiosity, see if you can remember what we call the top number. So take a moment and think about that. It's the part of the fraction that tells us how many parts we have. I hope we're all thinking the same thing, and that is the word numerator. Okay, so now that we have that settled, numerator and denominator, let's do a quick review of adding and subtracting fractions, something you've probably done a lot of in elementary school. Here on the left-hand side, we're going to write in a question to guide our learning, and that is how do we add or subtract fractions when the denominators are the same? For the most part, most of us have this down from what I have seen in class. An example of this problem might be 1/8 plus 3/8. If I look at that visually, right, that means I have 1/8, and I want to add to that 3 more 8s, right? That's all it is. The pieces are already cut to the same size, so I can just kind of add on to it. It's fairly straightforward. So when the two fractions are added with the same denominator, all I have to do is add the numerators. So that's 4, and of course I'm going to keep my denominator the same because the size of the pieces haven't changed just because I added them, right? I had 1/8, I had 3/8, and now I have 4/8. They are still 8s, I just have 4 of them. Now some of you are probably thinking, oh wait, that's the same as 1/2, right? And you're right. Remember our work with factors, right? We can factor numbers to simplify our fractions. 4 and 8 both have a GCF of 4, which means I can divide both of these by 4, right? And my fraction will remain the same value, but I've just rewritten it. Right? So 4/8 is the same as 1/2. Both of those answers are correct. The process for adding fractions with the same denominator is the same as the process for subtracting. So say, for example, we have 7/8, again I'll use 8s, minus 3/8. Right? The denominators here are the same. I have a visual here over on the side, right, that shows my 7/8 in red, and then I've crossed out 3 of those 8s in green. But once again, since the denominators are the same, all I have to do really is look at the numerators. And 7 minus 3 is 4, and those are still 8s. And once again, it ends up being 1/2, so it ends up being actually the same answer in both of my examples. Where students start to have a little trouble is when we try to add or subtract fractions that have different denominators. So once again, I went ahead and added a question there to guide us on the left-hand side. Make sure you do the same. For example, if we want to add 1/3 and 1/4, we can't just add the numerators here. So something I see a lot of is that students say, oh, 1 plus 1 is 2, 3 plus 4 is 7, right? This is not what we want to do. That will not work. Instead, in order to work through this problem, you'll need to remember our work with multiples. So we're going to find the least common multiple of 3 and 4, right, so that we can break our pieces both into the same size. So what is the least common multiple of 3 and 4? Right? You could make a list, you could do a cake, but hopefully know that the least common multiple of 3 and 4 is 12. So when we do our fraction work here, we're actually going to change our fractions. Instead of having thirds and fourths, we're going to change them into twelfths. Now, if I'm cutting my pieces into more pieces, right, and making them smaller, I don't still just have 1 here at the top, right? My 1 is going to get cut up as well. And so I can think to myself, well, I had to multiply my 3 by 4 in order to make 12. So I'm going to do the same thing on the top. 1 times 4 is 4. That's my new numerator. Over on the other fraction, I had to multiply 4 times 3 to make 12. So I'm going to do the same thing on the top. 1 times 3 is 3. Now, my fractions are the same denominator, and I can go ahead and use my original strategy. So I can say 3 plus 4 is 7, and keep my denominator of 12. And that would be my sum. That would be my answer. The same process is true for subtraction. I'm going to turn my page here just for a little bit more space. I still have my guiding question there over on the side. If you are still on the same page, there's no need to rewrite it, but do make sure you have it at least one time. And then let's go ahead and do an example here of 9/10 minus 2/3. Right? So again, here's what I see a lot of students do. I'm putting a not equal sign here. 9 minus 2 is 7, so sometimes people just put 7, and then 10 minus 3 is also 7, so they think this is their answer. This, of course, is not correct, right? They haven't taken into account that they have different denominators. So instead, we need to find our LCM, our least common multiple, of 10 and 3. And of course, we can do whatever strategy we need for that. But I know that 10 and 3 have a least common multiple of 30. And that's going to become my denominator. So I'm going to rewrite these fractions with 30s. So I'm going to put a 30 here and a 30 here. And then I have to think to myself, how did I get there, right? The tenths I had to multiply by 3 to make 30. Right? So I'm going to do the same thing to my numerator. And 3 times 9 is 27. As for my thirds, I had to multiply those by 10 to make 30. And so I'm going to do the same thing on my numerator, and 2 times 10 is 20. Now that I have everything with the same denominator, right, that checks out, same denominator, now I can go ahead and just subtract. So 27 minus 20 is 7, that's my numerator, but the pieces are still in 30ths. The answer is 7/30. So that was a quick review of adding and subtracting fractions that covered our essential question, which was how do we add or subtract fractions. We're going to spend just a mini unit on this in class to ensure that we have all practiced this skill. So feel free to come in with any questions that you might have kind of prepare for any extra practice you feel like you might need outside of class.